no calculator. So we're going to have the cube root of 125 multiplied by the square root of 25 plus the fourth root of 16 and then cubed multiplied by the cube root of 64 plus 1 over these 1 over, because it's negative, the square root of 49, and all of that is to the power of minus 2 over 3. Okay, let's simplify. This is 5 times 5 plus the fourth root of 16 is 2, cubed is 8, the third root of 64 is 4, and this is 1 over 1 over, so that just cancels, so it becomes 7 plus 7, and that is to the power of minus 2 over 3. So this is 25 plus 32 plus 7 is 64, and again to the power of minus 2 over 3. So this is 1 over because it's the negative power, and we're doing the cube root of 64 and then we're squaring. So that gives me cube root of 64 is 4, squared is 16, so it's 1 over 16. Beautiful. Love it. Okay, graph transformations. It says part A, sketch the graph of C clearly indicating the equation of the asymptote to the curve and the coordinates of any intercept. Well, any exponential function like this is just a line like that going through 1. So adding 1 to it is going to shift it up, which means that the asymptote line is going to be across at 1 and it's going to go through at 2. 2. Okay, so I'll just sketch that a bit neater down below. So we'll have this like this, we'll have an asymptote going through at 1, and then we'll have our curve coming up across there, up and up and up and up, and that's going to go through at 2. Okay, part B. Find an equation of the curve which is obtained by reflecting the graph of C in the x-axis, followed by a reflection of the graph of C in the y-axis. Okay, so the first off, the reflection in the x-axis is minus f of x, and then the reflection in the y-axis is f of minus x. So let's do that. Let's start with y is equal to 3 to the x plus 1. In fact, let's call it f of x. So minus f of x will just be minus 3x plus 1. And then if I were to change the x input to a negative, I would get 3 to the minus x plus 1 like this, which one could write as minus 3 to the minus x minus 1. Perfect. Okay, let's go up to part C. Describe fully a sequence of 2 transformations which map the graph of C onto the graph with this equation. Okay, so two transformations. Let's do it here. Well, what I can see here is that the x has been replaced with x plus 1. So that means f of x plus 1, which we know is a translation. By just, that's 1 to the left, isn't it? So like that. And I can also see that we've added on an extra 2. So that will be f of x plus 2. How should I write this? I'll write it like this. which means overall we're now translating it -1 and 2 up. Okay, so yeah, my answer is translation -1 plus 2. Okay, next one asks me to do it in a single transformation, which I think is actually quite natural, because this is 3 times bigger, because you're adding on an extra power of 3, and that is 3 times bigger than the original. So all I'm doing here is just multiplying through by 3 f of x. Because what would this give me? It will give me 3 lots of 3x plus 1 was the function, which gives me 3x times by 3, so like this, and 3 to the power 1, and then multiplied by, and then 3 multiplied by 1, which is what we need, which is 3x plus 1 plus 3. And anyway, this is a stretch in the y-axis scale factor of 3. Done. Question 11, we've got a cylinder, which is open at one of its circular ends, and it's got a capacity of 1500. Show that the surface area of A of the container is given by that. Okay, so first things first, we are actually going to look for the volume, because the volume is of course pi r squared times height, and we're also told that it's equal to 1500. And why do we do that? Well, this is then going to be able to give us an expression for the height, which we are going to use when we work out the surface area, because the surface area is not in terms of the height. Okay, how do I work out the surface area of a cylinder? Well, it's open at one of its circular ends. Okay, right, yeah, so it's open, so which means it's only got one circle. So pi r squared, because look, this is not need. There's no metal needed to do the lid. It's just the base that's needed, and the curved surface area. And the curved surface area is the circumference multiplied by the height, and that would give me a kind of a rectangle when I unravel the curved part. So it would be the height times by the circumference. So that is 2 pi r multiplied by h, and h we found is this. So therefore the surface area is pi r squared plus 2 times 1500 is 3000. The pi and the divide by pi cancel. The r and the divide by r leaves me with 1 over r. And that's what is required. Determine the value of r for which a is a stationary value. Okay, so that means that we need to just do the derivative of a with respect to r. So differentiating this is going to give me 2 pi r, and this is the same as 3000 r to the minus 1, so it becomes minus 3000 r to the minus 2 when I differentiate it. And I want that to equal 0 because it's a stationary point. I'm going to multiply everything by r squared, and that will get rid of the r to the minus 2. I'm then going to move everything over to the other side, so I'm going to get 3000 divided by 2 pi, So r is equal to the cube root of 3000 over 2 pi. So that's the calculator jobby. The square root, oh no, sorry, the cube root oh no, come on. Right, got there in the end. 5.81. Okay, next part, show that the value of r found gives a minimum value. Well, we need to do the second derivative test for that. So let's differentiate again, which is going to give me 2 pi. And we're going to get positive 6,000 r to the minus 3. Okay, and so when r is equal to 7.816, we can tell here that the second derivative will be greater than 0. And thus we have a minimum value. Because when you sub in r is equal to 7.8, that's definitely going to be greater than 0. Because we've got two positives there. So thus it makes it a minimum value. And then finally, calculate the minimum surface area. So I just need to take the area formula and sub in the value for r, which gives the minimum. So that's going to give me A is equal to pi 7.816 squared plus 3000 over 7.816. And I've put that in my calculator, and that's given me a value of 576. Exponential modelling. We have population P of seals on an island obeys this equation. K is a positive constant and T is time in years measured from a certain instant. Initially there were 175 seals on the island, so T equals 0, P equals 175. Find, showing detailed method, the value of T when the number of seals reaches 560. So we need to sub in our initial conditions to work out this constant K. So 175 is equal to 800k e to the 0.25t when t is 0 is just 1, and that's all over 1 plus again that will just be 1 times k, so k. Okay, great, so let's just rearrange this to get 175 plus 175. K equals 800k. So 175 is equal to 625k. So k is equal to 175 divided by 625, which gives us 0.28. Okay, and now we need to use that equation when the p-value is 560. So that gives me 800 times 0.28 e to the 0.25t all over 1 plus 0.28 e to the 0.25t. Great. Okay, let's multiply up. So I get 156 times 1, and I get 1 times 560, which gives me 560, and then I get 560 multiplied by 0.28, which gives me plus 156.8 e to the 0.25t, and that's equal to 800 times by 0.28, 224. Okay, I can just collect up the e to the 0.25s. So I'll just minus this to get 67.2. I'll then divide through by that 67.2. And I will get 25 over 3. And then we'll take natural logarithm of both sides. Give me this. And then I'll just multiply both sides by 4. And it asks me for the value of t, so I'm going to give that as a number, as this is a real life question. So t is equal to 8.48. And that is in years, I believe. Yeah, years. Okay, it says the long-term prospects of the population of these seals. Okay, well, let's just look again at the formula. Let's look it up here. And let's imagine what happens when t tends to infinity. Then we will have, on the top is 800 multiplied by 0.28, which was 224. And on the bottom we had just 0.28, and then this is e to the 0.25t, 0.25t, and that was plus 1. Okay, so basically, when you tend to infinity, that constant there is just going to disappear, and these are going to be huge numbers, so it will just be 224 lots of a huge number divided by 0.28 lots of a huge number, which will just be 224 divided by 0.28, which gives you 800. So it's going to tend to 800. Proof by contradiction, and we are asked to prove that if p and q are positive integers, then blah blah blah. Okay, so we do the opposite. We say assume that if p and q are integers positive, then p over q plus q over p is, what's the opposite of being greater than or equal to 2? It's being less than 2. Okay, find a common denominator of qp, which gives me p squared plus q squared. Multiply that denominator up. Gives me this. Move it all over to one side. It's going to give me this. It's always good to try and get it equal to 0. And this can be factorised. and that will be P minus Q times P minus Q. Yep, that works. Oh great, so that's P minus Q all squared, and this is a contradiction. As a square can't be negative, so it can't be less than 0. And then you need to write one final statement, and you say therefore the statement, which was P over Q plus Q over P, is always greater than or equal to 2 for all P, Q positive integers. Modulus question, and we have two functions and we're asked to draw them. So I will draw my sketch like this, and I will start by drawing the this function, which is just 1/3 x plus 2a over 3. So we know the y-intercept is going to be here at 2a over 3. We can set it equal to 0, which will give me that x is equal to minus 2a. So it's going to go through here at minus 2a. And that's it. We can draw that one now. Lovely. Label that one f of x. And the second graph, if I were to draw that without the modulus sign, it would have a negative y-intercept. Because again, a is a positive constant, so that's why we know that a is positive. And it will have a steeper line gradient, because it's 2x, so it will look something like this. And then of course I want to bounce that up. So it's going to have that V shape, so it's going to look something like this. And it was down there at minus a, so when it gets flipped over, it's going to be positive a, so it's going to be above the 2a over 3. And we also need to know where it crosses the x-axis, and that's when it's equal to 0. So how do I solve this equal to 0? Well, 2x must equal a, so a must equal x must equal a over 2. Okay, great, that's g of x, so we're done. We've sketched, and that looks good. And now we're asked to find the points of intersection. Okay, so that is when 1/3 x plus 2a is equal to 2x minus a, and that is also when 1/3 x plus 2a is equal to the negative of the modulus, which would be a minus 2x, or minus 2x plus a. Just, yeah, times it by minus 1. So we've got to solve these two separately. Multiply both sides by 3 to get 6x minus 3a. Solve for x, gives me 5x on this side and 5a on that side, so x just equals a. Over here, do the same thing, multiply through by 3, gives me this, gives me 7x on this side and 1a on that side, so x is equal to a over 7. Okay, great. They asked for the coordinates, so I will need to sub back in to find the y values. I think maybe the easiest one to sub into is the actual modulus function. So that was 2x minus a. So replace the x with an a. That gives me 2a minus a, which is just a. So here the y value is equal to a. And over here, we get two lots of a over 7 minus a. So 2a over 7 minus a is minus 5a over 7. But then when modulus, that just gives me 5a over 7. Great, so we've got two coordinates, a, and a over 7, 5a over 7. Beautiful. Okay, question 5. This is an arithmetic sequence question. It costs 5,000 to drill the first 10 meters into the ground. For the next 10 meters, it costs an extra 1,200 compared to the first 10 meters. Thus, it costs 6,200. Each successive 10 meter drilled into the ground costs an extra 1,200 compared to the cost of drilling the previous 10 meters. Find the cost of drilling 200 meters into the ground. Okay, so we're working in tens of meters. So essentially we want n equal to be 20 here. And the first 10 meters, so a is equal to 5,000. And the difference every 10 meters is 1,200. And again, n is equal to 20. So s of 20 is equal to 20 over 2. And then we have 2 times by 5,000 plus n minus 1 is 19 times by 1,200. Okay, so that can go into our calculator. 10 lots of 10,000 plus 19 times 1,200. And we get 328,000. And that's pounds. Okay. The company has a budget of 15 million. Determine the maximum depth in meters that can be reached on this budget. Okay, so let's set 15 million equal to the summation formula. N over 2, 2 times 5,000 plus n minus 1 times 1,200. Okay, times both sides by 2. I'm just going to write 30m for 30 million. And this is n times by 10,000. And we're going to get plus 1,200n. And we're going to get minus 1,200. So this is going to give us, that's 8,800 times n plus 1,200n squared. Set that equal to 0. Let's divide through by 100. Move the 30 mil over and divide through by 100 gives me 30,000. That's not right. 300,000. That's right. Brilliant. To the calculator we go. Menu. Equation. Polynomial. Degree 2. 1288 minus 300. I'm going to take the positive one, obviously. So n is equal to 154.5. Actually, I'll put 0.49. But that doesn't seem right because we already know that they can drill 200 meters for only 300k, but that's because n we took for every 10 meters. So n needs to be multiplied by 10 to get the total depth. Which gives me this to the closest meter. Okay, we've got a sequence and it's given by this recursive formula, and it says find the value of B4 in terms of K. Wowzer. Right, we know B1, so let's go to B2. And we just sub in K for Bn. So 5k minus 3. Great, and then we go to B3, and we just replace Bn with 5k minus 3. So we get 5 lots of 5k minus 3, which is the same as 25k minus 15 minus 3, which is 25k minus 18. And what do? We do it again. Yay. 5 lots of, this time, 25k minus 18 minus 3 is going to give us 125k minus 90 minus 3, which is 125k minus 93. Okay, given that B4 equals 7, determine the value of K. Sure thing. 125k minus 93 equals 7. 125k equals 100. So K is equal to 100 over 125, which is the same as 4 over 5. Bosh. Okay, question 1. We have a function, and it says the binomial expansion of f of x is in ascending powers of x up to and including the term in x squared. Okay, great. So we're going to use the formula. So I will start it down here, and we will have 1 plus nx, which is the power multiplied by whatever the x is. So that will be minus a third x. And then we will have plus n minus 1 over 2 factorial multiplied by whatever the x is squared. Okay, and that will all come out in the wash and give me, the 2 will cancel with the 2 there, a 3 and a 3 on the bottom, so that'll be a 9th. There will be a negative there, so it will be 1 over 9, and that will give me x squared. Okay, moving on, part B, we have this function, and it says use the result part A to find the binomial expansion of G in ascending powers of x. Okay, well, what we would do is, first off, we need to take out this 8, because we always need to have it as 1 in that slot there. So we'll write g of x is equal to 8 will come outside, and when it comes outside the bracket, we must take the power with it. And divide by 8 gives me 1, and divide by 8 gives me 3 over 8x to the power of 1/3. Okay, well, what is this then? So this is essentially 8 to the power of 1/3, and it is f of x, but the x has been changed to 3 over 8. of x. So what I'll need to do is take this out and just use my part A, but replace the x with 3/8. So I have 1 minus 1/3 3/8 x minus 1/9 3/8 x all squared. Okay, so 8 to the power of 1/3 is 2. And we're going to get 1 minus, the 3's will cancel there, so that's 1/8x. And the 3 squared is going to cancel with the 9, so we're going to have 8 squared on bottom, which is 1/64 x squared. Going to multiply through by 2, which is going to give me 2 minus 1/4 x minus 1/32 x squared. Perfect. Right, on to part C. Hence show that the cube root of 7 is equivalent to this. Okay, so we're going to be subbing into g of x, and we're going to want this bit here to equal 7. So 8 minus 3x we want to equal 7. So 3x will need to equal 1, so x will need to equal 1/3. So I need to sub in x equals 1/3 into g of x to get the cube root of 7. So g of 1/3 is going to give me 2 minus 1/4 times 1/3 minus 1/32 times by 1/3 squared. Okay, it gives me 2 minus 1/12 minus 9 times 32 is 288. Okay, just going to go to my calculator to check this is correct. I'm not going to do that myself. Bosh. Okay, so that's 1/288. Yeah, sounds good to me. Okay, trig equations. This one looks juicy. Right, we'll take this and we'll multiply it to the other side, which will give me 6 tan squared x minus 6 tan x is equal to 2 minus, and that's going to be 3, and sec squared is 1 plus tan squared. Great, so let's multiply out. To get 2 minus 3 tan squared x. Let's bring them all over to one side, and we'll get 9 tan squared x minus 6 tan x, and that's minus 1. Bring it to this side, plus 1 equals 0. Okay, let's factorize that. That's quite a nice, neat factorization. It will be 3 tan x minus 1, all squared. Lovely. And that equals 0, which means that tan x is equal to 1/3. And that means that x is equal to tan to the minus 1 of 1/3 is 0.322, and then the second solution for tan is plus pi, which is 3.463. Okay, great. That's that part done. Okay, part 2 we're going to need to use the double angle formula here, or the compound angle formula. So we have cos of 3 theta minus 60 is equal to cos of 3 theta plus 30. What does that give us? So that gives us cos theta cos 60 plus, so we always swap the sign over for cos, sine 3 theta sine 60 is equal to cos 3 theta cos 30 minus sine 3 theta sine 30. Okay, great. Next, let's use the exact values that we know. So we know that cos 60 is a half. We know that sine 60 is root 3 over 2. And over here, we know that cos 30 is root 3 over 2. And here we know sine 30 is a half. Okay, let's bring the sines onto one side and the coses onto another. So bringing the sines onto one side and factorising at the same time, we have root 3 over 2, lots of sine on this side, and then plus a half on that side, sine theta. And bringing the coses over to this side, we have root 3 over 2 already over there, and when we come across we're going to have minus a half. And all that's multiplied by cos 3, oops, that should be 3 theta, sorry. Okay, and then we can divide both sides by cos 3 theta and divide both sides by root 3 over 2 plus a half. So that will give us tan 3 theta on this side. And over here, actually, sorry, what I'm going to do first, I'm going to multiply everything through by 2. So that will give me root 3 minus 1 all over root 3 plus 1. Okay, now we take the inverse tan of that. So I'm going to need my calculator for this. We will do shift tan of root 3 minus 1 over root 3 plus 1. And we get 1 over 12 pi. But actually this question is in degrees. Whoops. So let's just swap it over by dividing by pi and timesing by 180. So 15 degrees. Okay, great. And obviously for tan we add 180, so that is 195 as well. Okay, and then let's see what happens when we divide through by 3. We get 5 and we get 65. And just checking the range again, it's up to 180. Okay, so it's up to 180, so that means that 3 theta is up to 540. So actually, I should have added another 180 here to make 375, because that is still within the 3 theta range. Dividing that through by 3 is going to give me 125. So these are my 3 solutions. Beautiful. Okay, trig modelling, and we are asked to put it into Rcos. So I'm just going to use my hack for this. And Rcos means I look at the cos coefficient here and I label that one A. And I look at the B coefficient and I label that one, the sine coefficient, sorry, I label that B. And then all I do is I say that r is the square root of 5 squared plus 12 squared, which is 13, and alpha is equal to tan to the minus 1 of 12 over 5. So that will be in radian mode. Apologies, I need to change that over. And I do tan to the minus 1 of 12 over 5. And I get 1 point, how many decimal places? To 3 decimal places, so 1.176. And that is done, just like that. Don't spend any more time on a question like that once you know the hack. State the maximum value of f theta and find the smallest positive value of theta for which this maximum occurs. Okay, let's do that then. So part B, we have f of theta is equal to 13 cos theta plus 1.176, and that's maximum when the cos function is 1. Can't get any bigger than that. So f theta max is equal to 13, and this happens when cos theta plus 1.176 is equal to 1. And cos is 1 at 0, but then I know that's going to give me not the answer I need, because if that's equal to 0, then I'm going to get a negative value, and it asks me for a positive 1. So the next time cos of a function equals 1 will be at 2 pi. So that's the one I need to use. So my answer will be 2 pi minus 1.176. So I'll do 2 pi minus 1, I'll just minus the previous answer, even better. Great, so 5.107. Okay, let's move on to part C. We've got this new function p, which is very similar, but let's just figure out what's changed. Well, obviously we've added on 20, but we've replaced theta with 4 pi over 25t. It says state the maximum pressure in the plant and the value of t for which this maximum occurs. Okay, so just like before, we can rewrite this as P is equal to 20 plus 13 cos theta changes to 4 pi t over 25 plus 1.176. Okay, great. And this hits a maximum when the cos is equal to 1, so we get P max is equal to 20 plus 13, so that's 33. And when does that happen? Well, again, that happens when cos of 4 pi t over 25 plus 1.176 is equal to 1. And once again, we're just going to take cos to the minus 1 of 1, and we're going to get 0 and 2 pi, but we know that 0 doesn't work because it will give a negative answer. So let's just run this through to get t. So I'll do 2 pi minus 1.176. I would then multiply it by 25, and I'll divide it by 4 pi. I'll get 10.16. Okay, let's underline some of these answers. Lovely. Okay, part D, it says find the times to the nearest minute when p is equal to 15. Okay, just going to grab some more space. So we'll get 15 is equal to 20 plus 13 cos 4 pi t over 25 plus 1.176. We're going to subtract 20 and then we're going to divide by 13. So we're going to get minus 5 over 13 is equal to this cos function. So what we're going to do next is we're going to do cos to the minus 1 of minus 5 over 13. Great. So we're going to get 4 pi t over 25 plus 1.176 is equal to 1.966. And we're also going to find the second value for cos, which is 2 pi minus. So we'll do 2 pi minus the answer. That gives me my second solution for cosine functions. So that is 4.318. Okay, and next what I need to do is just run them through that that formula to get t values. So I'm going to minus times by 25 divide by 4 pi, and I get 6.25. That was the second one. And after that, I'll do it the same for the first one. So that is 1.966 minus 1.176 times by 25 divided by 4 pi. And I get 1.57. Oops. Okay, and it asked me for the nearest minute, and t is the time in hours measured from midnight. Okay, so that is, if I take off the 1 hour, that's my decimal, times that by 60, that gives me the minutes. So it's 1 hour and 34 minutes. And I'll do the same for the other one. Well, that's just a quarter, isn't it? So a quarter of an hour is 15 minutes, and then 6 hours. So it's 06:15. Okay, question 9, we've got implicit differentiation. And we've got this equation here. And it says show that dy by dx. Okay, so I'm going to differentiate with respect to y. It's probably the easiest thing to do, and that gives me dx by dy is equal to the derivative of sec squared x is not trivial. You've got to bring the 2 down to the front, so you get 2 lots of the bracket, drop the power down by 1, and the derivative of sec is sectan, which is in your formula book, so you need to multiply through by that derivative. Okay, so the power comes down, you leave the bracket alone, you drop the power down by 1, and you multiply by the derivative of the bracket. And the derivative of tan is sec squared. Okay, great. So this now becomes, well, you've got a sec squared here. So we've got 2 sec squared y tan y plus sec squared y, which gives you sec squared y 2 tan y plus 1. and that's all equal to dx by dy. Okay, and now we can rewrite this because sec is 1 over cos, so we can write this as 2 tan y plus 1 over cos squared. Because again, cos and sec are reciprocals of one another, so if you've got sec on the top, it's the same as having cos on the bottom. And then all we need to do is flip to get dy by dx. So we get cos squared y over 2 tan y plus 1, which I think is what they require. Perfect. Okay, hence show that the equation of the normal to C at the point where y is equal to pi over 4 is given as this. Okay, so the normal gradient is the negative reciprocal. So the gradient m is equal to the reciprocal of this, a negative. So negative 2 tan, and the y value being pi over 4, plus 1 over cos squared pi over 4. Okay, so we can input that into our calculator. So it's the negative of 2 tan of pi over 4 is 1, so 2 plus 1 is just 3, and pi over 4, or cos of pi over 4 is 1 over root 2, so squared is 1 over 2, so that's 0.5, so the answer is just minus 6. Okay, great, so that's the gradient, but of course to work out an equation of a line we need an x and a y coordinate. So we have a y coordinate, but we're going to need to work out the x coordinate. Well, luckily we've got a formula for that. Sec squared of pi over 4, well, cos of pi over 4 is 1 over root 2, squared is 1 over 2, reciprocal is just 2. And tan of pi over 4 is just 1, so it's just 2 plus 1 is 3. Of course, you just put it into a calculator if you're not comfortable doing exact values. Right, so I've got my y minus y1 equals m x minus x1. Well, I've got m is equal to minus 6. I've got x was equal to 3 and y was equal to pi over 4. So we're going to get y minus pi over 4 is equal to minus 6 x minus 3. We're going to multiply through by 4, I think. To get this minus 24x. And that's going to give me positive 18 times by 4 is positive 72. Just quick check how they want it. The x and the y is on the same side, the constant on the other. So 4y plus 24x is equal to 72 plus pi. Job done. Happy days. Okay, we've got parametric equations, x and y, and it's asked us to find a. And we're given a point. So I'm going to sub the x into here and the y into here. Okay, so part A, that gives me the x was 20 and it was also equal to 2at, and the y coordinate was 60 and that was equal to 8at minus at squared. So dividing through by 2, this gives me that 10 is equal to at. Can't do much else with that. So let's look at this one. I've got 8at here, and I know that at is 10. So that gives me 80. Rearranging, I get at squared is equal to 80 minus 60, which is 20. And now I've got 2 simultaneous equations which I can solve. I can divide one by the other. So I'll do AT squared is equal to 20 divided by AT is equal to 10. And this gives me that T is equal to 2, which means therefore A is equal to 5, because A times T equals 10. Great. So A equals 5. And then next we've been asked to work out the Cartesian equation. So if I just rewrite the equations that we have so far, we have x is equal to 2at, but we know a is 5, so that's going to be 10t. And we have y is equal to 8at, which is going to be 8 times 5, so 40t. And then minus at squared, so that's going to be minus 5t squared. So I'm going to rearrange the x1 to make t the subject. And then I'm going to sub it into the y1. So I get y is equal to 40 x over 10 minus 5 lots of x over 10 squared. So this gives me y is equal to 4x, and that's going to be 5, that's going to be over 100, so 5 over 100 is 20, so minus x squared over 20. Okay, let's go onwards. It says the set of parametric equations represents the path of a golf ball t seconds after it was struck from a fixed point on the ground. The horizontal distance of from O is x meters, and the vertical distance above the ground level is y meters. The ball hits the lowest point of a TV airship which was recording the golf tournament from the air. Assuming that the ground is level and horizontal, find the greatest possible height of the airship from the ground. Okay, so it's just basically asking us to find the maximum y value. So I could differentiate the function, and that will give me 4 minus x over 10, and set it equal to 0, which gives me 4 is equal to x over 10, which gives me x is equal to 40. We want the highest y value, so I would just sub that into my y equation. Yeah, like so. And I get 80. So y equals 80 meters. Question 8, and we've got parametric equations and we've got differentiation. So if I want to find dy by dx, then I'm going to need to work out dy by d theta and divide it by dx by d theta. So the derivative of the y function here is just going to be 2 cos theta, and the derivative of the x is going to be minus 2 sine theta. Okay, and then what we can do is we can rearrange and get an expression for cos and sine. So cos theta is x minus 3 over 2 by rearranging this equation, and the y1 sine theta is y plus 3 also over 2. So dy by dx, the 2's will cancel and we have just cos over minus sine. So cos is x minus 3 over 2, and that's over minus y plus 3 over 2. Okay, the 2's will cancel, so I get x minus 3 over y plus 3, and I can take the negative just outside, and I can apply it to the numerator rather than the denominator, which will give me 3 minus x on top and 3 plus y on bottom. Brilliant. Okay, we've got a parametric integration question which looks substantial. It says the curve lies entirely above the x-axis and has these parametric equations. The finite region is bounded by the curve, the x-axis, and the straight line with equation x is equal to 1/2. Okay, so let's just quickly sketch it. We know that it's bounded by the x-axis and the line x equals 1/2. And we also know that when t is equal to 0, we get 0 from that, and we get 0 from that. So we know it goes through the origin. So from that, it doesn't really matter what the graph does, because this is the region which we're going to calculate, and we're going to do that via integration between the limits of 0 and x equals 1/2. Okay, so what we need for parametric integration is we need dx by dt. So I know that x, well, we just differentiate this basically. So the 2 comes down to the front. We keep the function sine t the same, and we drop the power down by 1, and then we multiply by the derivative of the bracket, which is cos t. So this is 2 sine t cos t. We also need to know what our limits are when we do parametric integration. So I draw a little table like this, and I write x here and I write t here. Now the x coordinates that we're integrating between are 1/2 and 0. So I need to find the t equivalents by using the x equation. So I'll start by saying 1/2 is equal to sine squared t. Square rooting gives me 1 over root 2 is equal to sine t. And arc sine of 1 over root 2 is pi over 4. So we get pi over 4 as our limit there. And then I also need to do 0 is equal to sine squared t. And we know this just gives me t equals 0, because sine is 0 when the input is 0. Okay, so we're good to set up our integral now. Our integral, if we remember the parametric equation, is y dx by dt dt. So this is going to give us the integral between our new limits of y, which was 4 tan cubed t, times dx by dt, which we said was 2 sine t cos t dt. Let me just double check that is correct. Yes, that is good. Okay, so what I could do is I could take an 8 out, and I can write tan cubed as sine cubed over cos cubed to get it all in terms of sines and coses. Sine t cos t dt. And this is going to give me sine to the power 4 t on top over cos squared on bottom dt. And again, let's take the 8 here, and not to forget our integral sign. Okay, well, I'm afraid we're going to have to replace the sine to the power 4 here, and we're going to need to we want it all in terms of cos. So what I'm going to do is I'm going to write it as 1 minus cos squared t times 1 minus cos squared t, which is the same as sine squared times sine squared, which is sine to the 4, all over cos squared t. Okay, great. I'm pretty confident this is going to work. And this is going to give me 1 minus 2 cos squared t plus cos squared, cos to the 4 t over cos squared t. Great. Right, I can rewrite this as 1 over cos squared is sec squared, minus 2 and plus cos squared t dt. Okay, we need to do a substitution here. So we know that cos of 2t is equal to by the double angle formula, 2 cos squared t minus 1. So cos of 2t plus 1 multiplied by a half is equal to cos squared t. So I can now integrate sec squared t minus 2, and this will be the same as plus 1/2 cos 2t plus 1/2. So now let's do the integrals. And we will get, well, the derivative of tan is sec squared, so the integral of sec squared is tan. That's going to be, we've got minus 2 and plus a half there, so that's minus 3 over 2. So that's going to integrate to minus 3 over 2t. And cos integrates to sine, and the derivative of 2t is 2, and we divide by the derivative, so we half, and there's already a half there, so it's a quarter. So it's a quarter sine 2t. And that is between pi over 4 and 0. Okay, let's sub in our limits. Pi over 4, tan of pi over 4 is 1. Minus 3 over 2 times pi over 4 is minus 3 pi over 8. And pi over 4 doubled is pi over 2. Sine of pi over 2 is 1, so that's just plus a quarter. And when I sub in 0, these are all going to be 0, so I don't need to do that. So I'm going to get 8 minus 3 pi plus 2, which is the same as 10 minus 3 pi. Boom! We are done. MADAS the goat. It's like a Newton-Raphson question, and it says show that the above equation has a root alpha which lies between 0 and 1. Classic. Well, we're going to say f of x is equal to x cubed plus 10x minus 4. We're then going to sub in f of 0, and we're just going to get minus 4, which is negative. And we're going to sub in f of 1, and that is going to give us 1 plus 10 minus 4, which is 7, which is positive. And then we're going to say, as f of x is continuous, and there is a change of sign on the interval 0 to 1, then there is a root. I think that should be sufficient. Key things to remember: continuous, change of sign. Okay, Newton-Raphson method twice, starting at a half to find correct 4 decimal places and approximation of alpha. Great. So that was part A. This is part B. We're going to need to differentiate the function. So we're going to need to find f dash of x, which will be 3x squared plus 10. And then we will say that xn plus 1 is equal to xn minus f of xn minus f dash of xn. So this is xn minus, and the function was x cubed plus 10x minus 4, and the derivative was 3x squared plus 10. Okay, great. So all we need to do now is use x1 0.5 to get an approximation for x2. So we'll go to our calculator, and I'm going to use this little hack. Recursion, delete. We will type in the formula of an minus an cubed plus 10 an minus 4 over 3 an squared plus 10. And we will we'll do 6. Why not? Why not? Let's treat ourselves. And start at half, hit the table button, and we get first one 0.3953, and the second approximation 0.3938. Beautiful. Here we go, cheeky integration by parts via integration by substitution. And MADAS has been a bit cheeky here, not telling us what the substitution is, but don't worry, don't fear, we can figure it out, because we need to look at the most annoying part of the integral, and that is this fourth root of x. So let's sub that right out. And let's say that u is equal to x to the quarter, and we can square that, which will give me x to the half, which is of course root x. So this is where we're going to get this double substitution here. Lovely. Okay, we need to differentiate, so du by dx is equal to, in fact actually no, I'm not going to do that, because my one rule is I don't like, when I do integration by substitution, I don't like the square roots getting involved. So instead I'm going to square again to get u to the 4 is equal to x. I'm going to differentiate that. Brilliant. 4u cubed du by dx is equal to 1. So 4u cubed du is equal to dx. Oh, it's much better. Don't forget to set up our limits. X, u, 1, 0. 1 fourth rooted is just 1. And 0 fourth rooted is just 0. Okay. Okay, so the integral is still between 1 and 0. And we have e to the u on top, and we have u squared on bottom. So we have e to the u on top and u squared on bottom. And then we have dx which needs to be replaced with 4u cubed du. Great. So this is 4, which can go outside of the bracket, or the integral, sorry. U cubed over u squared is just u. So this is u e to the u du. And this is where the parts is going to come into it. So I'm going to use the DI method here for integration by parts, because it's just so efficient. U here, e to the u here, differentiate that gives you 1, 0, integrate that gives you the same thing. So the answer is just that times that, and that times that, and then we also integrate the final row, but that's just 0, so we can forget about it. So we get 4 lots of u eu minus e to the u. When we sub in, we get that's just e minus e, comma, comma, minus, sub in 0, and that's 0, and that's minus 1. Okay, so that's 0, and that's positive 1, so it's just 4. Splendid. Okay, we've got a beast integration by partial fractions. Let's do it. First off, I'm going to need to factorise the bottom of this fraction. So we will have, I won't write the integral sign every time. Let's just do the partial fractions first. So that's x minus 1 minus 2. And this one is going to be x minus 1, x minus 1. Interesting. Okay, so we're going to have to set that equivalent to a over x minus 2 plus b over x minus 1 cubed plus c over x minus 1 squared plus d over x minus 1. Wowza. And then we're going to multiply up. So we're going to get 2x cubed minus 5x squared plus 5 is equivalent to a x to the minus 1 cubed plus b x minus 2 plus c lots of, there'll be an x minus 1 and an x minus 2, plus d lots of, there'll be x minus 1 squared and an x minus 2. Crazy. Okay, you know the drill. We let, we let x equal minus 1 to start, or plus 1, sorry, plus 1 of course, which will give me 2 minus 5 plus 5, which is just 2. And all of the ones with x minus 1 are going to cancel, so we've just got this b term here, which will be 1 minus 2, which is minus 1, so minus b. So therefore b is equal to minus 2. And then we let x equal 2, and we're going to get 8, 16 minus 20 is minus 4, plus 5 is 1. And then the minus 2's, the x minus 2's will all cancel, which just leave you this a term here. When x is 2 minus 1, we get 1, cubed is 1, so it's just a. So we get a is equal to 1. Okay, so we've used all of our numbers which can cancel stuff out. So when you do that, you just pick any number really, and let's let x equal 0. Because when x equals 0, we get 5 is equivalent to, this will be minus a, so that's just minus 1. Over here, we'll get minus 2b. Times by minus 2 is that's plus 4. And then here we're going to get minus 1 times minus 2 is positive 2, so plus 2c. And here we will get, that's just 1, because it's squared, and then times by minus 2, so that's minus 2d. Okay, so that tells us that 2c minus 2d is equal to 2. Okay, so because we've got so many, we're going to need to, still got 2 unknowns, we're going to need to do another one. So let's just go for x is equal to 3. I think that might be the best option. I'm going to have to sub that in up here, and we're going to get 2754 minus, so that's a total of, that's 14. And we're going to get here 2 cubed is 8, so 8a, a is 1, so that's just 8. 3 minus 2 is 1, and b is minus 2, so that's just minus 2. And we're going to get 2 times 1, which is just 2, so 2c. And we're going to get, that's going to be 2 squared is 4, times by 1, so 4d. So it looks like we've got 2c plus 4d, and that is going to be 6, so that's going to be equal to 8. Okay, so simultaneous equations. Let's subtract up, which is going to give me 4d minus 2d, so that's 6d is equal to 6, so d is equal to 1, and therefore we will get that c is equal to 2. Brilliant. Okay, right, now now over to our integration. So let's set it up. So it's the integral of between 1/2 and 0 of a is 1, so 1 over x minus 2. B is minus 2, so that's, and these ones because you've got a power on the bottom, the best way to integrate that is just to write it as a negative power on the top. So b was minus 2, and that was x to the minus 1, so x minus 1 to the power of minus 3. And c is 2, and that would be x minus 1 to the power of minus 2. And the last one is just 1 is d, so 1 over x minus 1. Okay, so we can integrate these. This one is going to go directly to ln of x minus 2. Here we're going to up the power to minus 2. We're going to divide by the new power, so that just gives me 1. And we're also going to divide by the derivative of the bracket, but that is 1 itself. So this is just going to give me x minus 1 to the power of minus 2. Here we're going to up the power to minus 1, divide by the new power, which is just give me minus 2. And again, the derivative of the bracket is just 1, so dividing through by that will keep it the same. And this is going to integrate directly to a ln. And that is between minus 1/2 and 0. Okay, so subbing in, we will get ln of 1/2 minus 2 is minus 3/2, but the modulus sign will save us. So that's ln of 3 over 2. Here we have a half minus 1 is minus a half. And then square it is a quarter. And then flip it is going to give me 4. This one we're going to get minus a half again, and we're going to flip it to get minus 2, times it by minus 2 is going to give me 4 again. And here we're going to get a half minus 1 is minus a half, modulus it 1/2. Okay, take away, subbing in 0, this is going to give me ln of 2 once it's been modulused. This is going to give me minus 1 squared is 1. And this is going to give me, again, minus 1 to the power of minus 1 times by minus 2 is just plus 2. And this is going to give me ln of 1, which is just 0. Okay, let's look at all the lns first. We've got positive, positive, and a negative. So this is the same as ln of 3 over 2 times 1 over 2 over 2. Positive ones go on top, negative goes on the bottom. And in terms of our number terms, we've got 4, 4 makes 8, and then minus 1, or just minus 3, so that's just 5. Okay, and what is this ln? This is 2 and 2 on bottom and another 2, so that's 8, so it's 3 over 8 and then plus 5. Beautiful. Okay, integration by substitution. I'm going to start by differentiating the substitution with respect to x. So I'm going to get 2u, but that is respect to u, so I need to multiply it by du by dx, is equal to e to the x differentiates to itself, and we're good. Okay, let's multiply it up to make to get the dx on that side. And I can divide through to get dx as the subject, and that's going to be helpful when I sub it in, because it's going to cancel it's going to cancel an e to the x, which will be helpful. Okay, next what I'll do is my limits. So I'll do x and I will do u. And x we have ln 5 and ln 2. And when I put it into the substitution, I will get ln x of ln 5 is just 5, minus 1 is 4, so u squared equals 4. So u is equal to 2. Ln 2 goes in, and that gives me 2 minus 1, square rooted is 1. Great, so those are my limits sorted. And I'm also going to just write u is equal to the square root of e to the x minus 1. And I'm also going to write e to the x is equal to u squared plus 1. That might be helpful. Okay, now to do the substitution. So I'm going to have 2 and 1 on top. I'm going to have 3 e to the 2x. Now I can write that as 3 e to the x times e to the x. And that's all over the square root of e to the x minus 1, which we've just shown here is u. And we've also got dx, which is 2u du over e to the x. Okay, so we're going to get the u's cancelling, 1 on top, 1 on bottom, and then e to the x cancelling, 1 on top, 1 on bottom. So we're going to get 2, 1, and we're going to get 2 times 3, which is 6, which I can take outside as a constant. And I'm just going to be left with e to the x, which we know is u squared plus 1 du. Okay, perfect. So let's just integrate that. Up the power and divide by the new power. Up the power and that's between 2 and 1. Subbing in, we're going to get 2, that makes 8, so 8 over 3, plus 2, minus, sub in 1, 1/3 plus 1. I'll put that into my calculator, press execute, and then multiply that all by 6 to get an answer of 20. Bosh. Question 13. Oh, what a beautiful question. Really tricky, this. A container is the shape of a hollow inverted cone. Has a base radius 20 centimeters and height 80 centimeters. The container is filled with water and is supported in an upright position. Okay, first off, I just want to draw a quick diagram. So it's going to look something like this. And I'm going to show you the little secret to this question. So we have a radius of 20 and we have a height of 80. Okay, so that means that because we're in proportion, if I have however much water I have in here, the radius and height will be in the same proportion. So that means that the radius divided by the height will always be in the same proportion as what it was originally, which was 20 divided by 80. So that means that the radius is equal to 1/4 of the height. And that is going to be absolutely critical. Okay, water is leaking out of the hole at the vertex of the cone. Let h be the height, blah, 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 blah. Yep. The rate at which the volume of water is decreasing is directly proportional to the height of the container. Okay, right, that is something which we can use. So the volume of the water, the rate of the volume, so that is dV by dt, and that is proportional to the height, and it's decreasing, so it's proportional to minus h. So we can say that dV by dt is equal to minus kh. By relating the measurements of the container to that of the volume of the water, show that dH by dt. Okay, so we need dH by dt. So what else do we know about this cone? Well, we know the volume of the water inside is going to be 1/3 pi r squared h, because that's the volume of a cone. So what I can do is I can replace the r with 1/4 h. So I can write v is equal to 1/3 pi, and then that's 1/4 h squared h. So v is equal to, that's going to be 1/48, 16 times 3, yep, and that's going to be h cubed, and we're also going to have a pi. And I can differentiate that with respect to h to get 1/16 pi h squared. And that's great, because what was I looking for? I was looking for dH by dt. And now I've got this and I've got this, which I should be able to use to get dH by dt. So I want a dt on the bottom, so I'm going to have dv by dt there, and I want a dH on top, So I'm going to flip that one over like that, and as such the dv's will cancel perfectly. Okay, so I just need to sub in now. dv by dt we know is minus kh, and that needs to be flipped over, so that will give me well, 16 will go onto the top, and we'll have pi over h squared on the bottom. So this gives me minus k h, oh no, so h will go, so it'll be times 16, and that'll be pi h on bottom. And then what we could do is we could do a constant swap, where we can say that capital A is the same as k multiplied by 16 over pi, which will allow us to write that dh by dt is equivalent to minus a over h. And I believe that is what we were asked for. Beautiful. Okay, and now it says, it gives us a condition. That's useful. But we're going to need another condition because we're going to have two constants, and I think that, okay, I think we can use the initial one. Determine the value of t by which all the water will have leaked out. So it needs to solve this differential equation basically. Okay, so separate the variables. We're going to get h dh is equal to minus a dt by multiplying up from either side, and then we're going to integrate. This is going to give me a half h squared, and this is going to give me minus a t plus c. So we're going to need two conditions, like I said. We've got given one here, and the other one is that we start with a height of 80. So let's go with t equals 0, h equals 80 first. So that's going to give me 3,200 is equal to c. And then we're going to use the other condition, which was t equals 1, h equaled 78. So this gives me a half 78 squared is equal to minus a times 1 plus 3,200. So I'm going to need a calculator for this. 3,200 minus 0.5 times by 78 squared. I get 158 as a. Okay, great. So my complete equation is going to be 1/2 h squared is equal to minus 158t plus 3,200. Man, I love differential equations. Determine the value of t by which all of the water would have leaked out of the container. So we need to find when h equals 0. So h equals 0 means we have 0 is equal to minus 158t plus 3,200. So we can solve for t just by doing 3,200 divided by 158, and we get 20.25. And I think that is measured in minutes. I just need to check. Apologies. Yeah, t measured in minutes. So let's just call that 20.25 minutes. Love it.